Okay, this one, you have to start with L'Hopital's rule, but then once you take L'Hopital's rule, you have to actually do it 3 more times if you want to use L'Hopital's rule all the way until the end. So it's much easier if you just use things we learned before. Okay, so first step, you do have to use L'Hopital's rule, but the second step and beyond, you don't have to use L'Hopital's rule. Okay, try that one. All right, for the sake of time, let me just kind of show you. So basically, this one, you're going to use L'Hopital. And then you get secant squared x minus 1 over 3x squared. If you put in 0 right now, you're still going to get 0 over 0. Oh my gosh. Okay, sorry, give me 1 sec. So secant squared minus 1 is tangent squared. 1 plus tangent squared equals secant squared. Okay, this is tangent squared is sine squared over cosine squared, right? Remember, this is the limit as x goes to 0, so this thing goes to 0, goes to 1. Remember that rule? Limit as x goes to 0 of sine x over x is equal to 1. Much easier this way. So that's going to be 1, and a cosine square of 0 is 1, so the answer is 1/3. Or else you have to take L'Hopital's rule 2 more times, and that's going to take too long. Because you need to reduce it so that it never gets 0 over 0 again.
So do we need to write L'Hopital like every time? Like, do we need to prove that we can use L'Hopital every time?
If you want to use it, yes.
So we need to write like 3 more times?
Yes, if you want to use L'Hopital all the way, yeah.
Why don't we give it cosine square?
Because cosine of 1, cosine of 0 is 1.
Oh, okay.
All right, let's take out our notes and put away our iPads. We are going to do day 2 of L'Hopital's rule. All right, so L'Hopital's rule, we said it is applied to indeterminate form. And can you give me an example of indeterminate form? 0 over 0.
Infinite over infinite.
Infinite over infinite, or negative infinity over infinity. Negative infinity, right? Okay. Now, what is this equal to? 0 over infinity. 0, okay? It is not an indeterminate form. And then what's infinity over 0? Indeterminate or does not exist. Okay, those are not indeterminate form. Indeterminate means that we don't know which one's bigger. We have no idea. Could be a limit, could be no limit. We have no idea. So these are our indeterminate form. All right, now we are going to look at other types of indeterminate form besides the ones that we just learned. 0 over 0, infinity over infinity. The first type that is kind of strange is 0 times infinity or 0 times negative infinity. So that is type 1 or one of the other types of indeterminate form. 0 times infinity is not 0. 0 times negative infinity is also not 0. We don't know. It could be 0, it could be something else, but it is too much of an assumption to say 0 times a super big number is actually going to get you 0. So we need to double check. Okay, so for example, this one. Huh? Okay, well, let's look at this question. Limit as x goes to 0 plus of x times natural log x. All right, so if you plug in 0 right now, what do you get? Well, if you plug in 0 in x, you get 0. If you plug in 0 into natural log x, you get negative infinity, right? So that's a 0 times negative infinity. We don't really know what that number is. Basically, you can't just time the number by 0, a very big number by 0, and just say, like, gone. That number is gone. It's too big of a number to say it's gone. Like, if you do 10 times 0, it's 0. Yeah, that's for sure. But if you have a super big number, you cannot just assume. All right. Okay, so we are going to force it into a L'Hopital's rule. That means we need to make it look like an indeterminate form that L'Hopital's rule will accept. Basically, we can only use L'Hopital's rule when what happens? How does the limit have to look like if you want to use L'Hopital's rule? Indeterminate form, which is 0 over 0 or infinity over infinity. So we have to force this 0 times negative infinity to look like 0 over 0 or infinity over infinity. Okay, so here's what you do. Okay, I'm going to write this question again. You don't have to write that again. Okay, so what we're going to do is make it into a quotient. So this x, what I'm going to do is I'm going to change this x so it's in the denominator. Okay, so here's what you do. If you're not really sure what to do, you take this x value, you find the reciprocal, and then put it in the denominator. What is the reciprocal of x? 1 over x. So just put 1 over x in the denominator. Does that make sense? Kind of? Okay, now let's look at what happens. Okay, do you have a question about how to change that x into 1 over x and put it in the denominator? Or how is that the same? Okay, you guys are good? Okay. All right, now let's look at this question again. So we have now natural log x divided by 1 over x. Okay, let's look at each limit separately. So the limit as x goes to 0 plus of natural log x is still negative infinity. What is the limit as x goes to 0 plus of 1 over x?
Infinity.
Infinity. And that's an okay L'Hopital's rule, infinity, negative infinity over infinity. So basically, we have forced this to become a form of negative infinity over infinity. We can use L'Hopital's rule. Does that make sense? So when we get to another indeterminate form and we cannot find the limit, you make it look like a L'Hopital's rule indeterminate form. Then use L'Hopital's rule. Okay, so now use L'Hopital's rule. So limit as x goes to 0 plus the derivative of natural log x is 1 over x, sorry. And then the derivative of 1 over x. Negative 1 over x squared. So try to memorize that. 1 over x, the derivative of 1 over x is negative 1 over x squared. Just think it's negative and then add another degree in the denominator. It will make your derivative faster. Okay, so this becomes limit as x goes to 0 plus of 1 over x times negative x squared. Right, flip it back up, which is equal to limit as x goes to 0 plus of negative x, which is 0. Okay? You guys are like, I knew it was 0. All right, let's practice with this one. Okay, what's going to happen if you put in infinity right now?
It'll just go over that.
Yeah, infinity times infinity, right?
Yeah.
Infinity times infinity. Actually, no.
Times 0.
Infinity times 0. We're going to get infinity times 0 right now. Can you guys see that? Yeah? Okay, so we need to change it into a L'Hopital's rule thing. How should we do that? Okay, what can we do with this x cubed? Put in a denominator. If it goes in the denominator, what is it going to look like? Yeah, 1 over x cubed. Okay, now both of them will go to what? No. 0. Both of them are going to go to 0. Limit as x goes to infinity of e to the negative x squared. That is e to the negative infinity. That is 1 over e to the infinity, which is 0, right? Okay, and then limit as x goes to infinity of 1 over x cubed is obviously 0. Huh? Why did I change e to the negative x squared to 1?
Why wouldn't you put the e to the negative x squared on the denominator?
Oh, because negative exponent means flip it, right? Flip the whole thing. So, yeah, I could have done that in the first place. You would still get the same problem. So if you did x cubed over e to the x squared, you would get, oh yeah, infinity over infinity, yes. Yeah. Okay, that's true. Okay, so you're going to have to use L'Hopital's rule. Okay, so go ahead and use L'Hopital's rule, either this one or this one. So either way. Use L'Hopital's rule and you got to find the limit. All right, okay, so let's do the simpler one. Okay, so limit as x goes to infinity of x cubed over e to the x squared. That is infinity over infinity. That means we gotta use L'Hopital's rule. Okay, so that is the limit as x goes to infinity of 2x squared over e to the x squared times 2x. Right? Chain rule, right? So take the derivative of the top, which is 3x squared. Take the derivative of the bottom, e to the x squared. Chain rule times 2x. Yes?
Shouldn't there be 3x squared?
3x squared? Oh, I'm sorry. Yes. All right, so now plug in infinity again. What do you get? Hmm? What? If you plug in infinity, okay, well, we can reduce. But if you plug in infinity, what do you get?
1 over infinity. Oh, no.
Infinity over infinity, still, right? Yes?
But above all that is decrease faster.
Yes, you're right. So at this point, you could just say, I'll apply chapter 2. The bottom is increasing much faster than the top. Answer is 0. Yes, the answer is 0. If you, at this point, you're like, I still cannot tell what the answer is, take derivative one more time. So apply L'Hopital's rule one more time. Okay, how are you guys doing? Talk to me. Get it, not get it? Kind of. Okay, so at this point, you remember you don't have to use L'Hopital rules on everything. You could just say, oh, the bottom is e to the x. It's not just e to the x, it's e to the x squared, super fast. And then on the top, it's a 3x. It's a very slow increasing monomial. So the bottom is increasing much faster than the top, it's going to be 0. If you cannot tell, do L'Hopital's rule one more time. Okay, that's going to be 3 over 2 times e to the x squared times 2x again. Now you can see that if you plug in infinity, the only thing that is moving is the bottom. So definitely 0. Good? Not good. Nobody's saying anything. I'm good. No good.
I think we're a bit fried.
Yeah, I hear ya. Okay, let's do one more type and we're gonna call it a day. We have 3 types, but I think we have time for just 2 types. Second one, infinity minus infinity. Infinity minus infinity is not 0. Because, no, that's like the worst thing that can happen. 3 infinity minus 2 infinity is a 1 infinity. No. Okay, we don't know if this infinity is a little bigger than that infinity or not. Not all infinity are created equal. So when you put numbers in right now, natural log, okay, so if you put 1 in, you get 1 over natural log 1 over 1 minus 1. Natural log 1 is 0, right? So 1 over 0 minus 1 over 0. That is not 0, okay? That is not 0. That is infinity minus infinity. So we don't know. This is another example where you do need to use L'Hopital's rule. But again, it is not in the form of L'Hopital's rule yet. We have to get it into an infinity over infinity or 0 over 0. Okay, so this one's not too hard. We just need to combine those two terms into one. That way we just have a quotient rule or a quotient in general. So we are going to multiply the left by x minus 1 and then the right by a natural log x, and then I'm going to combine the two denominator together. Now what happens if I plug in 1? Nothing? Okay, so 1 minus 1 minus natural log 1 is what? 0. And then the denominator. 1 minus 1, 0. Right, so now I made it into a 0 over 0. So I can use L'Hopital's rule. All right, go ahead and use L'Hopital's rule and figure out what the answer is. All right, so if we take L'Hopital's rule, we get 1 minus natural log x over x minus 1 times 1 over x plus natural log x. Okay. Put 1 in there, you still get, what do you get actually? 0 over 0. L'Hopital's rule one more time. You don't want to do product rule. So what you want to do is just like multiply this whole thing out, right? So 1 minus what? 1 over x. And this is really 1 minus 1 over x plus natural log x. Much easier to take the derivative of each term than a product rule. Okay, L'Hopital's rule one more time. Okay, L'Hopital's rule one more time. 1 plus 1 over x squared over, I'm sorry, there's no more 1. What am I doing? 1 over x squared over 1 over x squared plus 1 over x. Plug in 1 over 2. All right, that's it for today.